All right, in this video, we're going to be using the slope of the tangent to approximate the change in y. So basically, they want us to find dy. Well, if we take the derivative, we are now creating dy dx. So we now just introduced dy. So we write dy dx equals. And if we now cross multiply, we end up with dy equals 3x squared plus 4x times dx. Remember, these are the approximate change in y over the approximate change in x. It's the rise and run for our tangent. And so now we have an equation for it. So part A is done. We just found dy dx. The question now is, find the value of dy when x is 2 and the change in x is 1. So all you have to do is plug those values in. So we plug in 2, and then our dx, which is our change in x, is 1. So that means what we're doing is we're going from x equals 2, and then we're going to have a change in x of 1. So we're going to go from x equals 2 to x equals 3. And we want to see how is our y changing. That's what dy does. So if we figure this out, this is 3 times 4. It's 12 plus 8. That's 20 times 1 is 20. So what we basically did here is, if you think about it this way, this is dy over dx is equal to 3x squared plus 4x. We have dy over 1. And then by plugging in 2 here, it gives us 20. So if you think about it this way, if you have a change in x of 1, what does your change in y have to be so that we end up with 20? It's 20. So by making a formula, it can give us our change in y. But what does it look like graphically? So here we have our actual function here. This one is the x cubed plus 2x squared. We're going from 2 to 3. So you can see our y value went from 16 to 36. So 36 take away 16 is 20. So that's all we were using the formula for, to figure that out. But the actual change here went from 16 to 45. So our actual change in y went from 16 to 45, which is 29. So this is 29 over 1, and this is 20 over 1. So the tangent is just giving us an approximation of the actual change. And so that's what we're looking for when we find dy. Thank you. So by finding the derivative, bringing the dx to the other side, it gives us a formula to find an approximate change in our y compared to our actual change in y.